Hey guys, how's it going? So this is your Monday lesson. Hello, it's Mr. B. I hope you guys had a good weekend. So we're going to be talking about lesson 11. And so we're going to learn about different types of forces that we have in our unit. And so you'll get to do an experiment today, which I have right here. So it's a licorice force experiment. So I'll go over this after I've finished explaining the different types of forces that we have in this unit and which ones you're going to be going over in this experiment. So we have, I'll just take you quickly through the PowerPoint to talk a little bit about the different terms that we have that you guys can add to your notes or just have this PowerPoint available to you guys later, however you want to do it. And so here we go. So forces are on a structure are either classified into live loads or dead loads. So live loads change. Think about that as like a car crossing over a bridge. That's a live load because the weight is not always on the same spot. It's always moving. And then there are dead loads. So those are forces that do not change. So the weight of the structure itself, like the beams and the metal and all of that stuff on the bridge are a dead load, whereas a live load would be the cars going across it, the people walking across it, and stuff like that. So those are two new terms that you can add to your definitions, your live loads and your dead loads. As we move on here, when a force is applied on a structure, it causes forces in the structure. So what that means is that the forces that are applied cause a change in the structure. So these forces are either external, so those are forces that are applied on a structure, and then internal forces are within the structure themselves. So an example of that would be an external force would be like gravity. So that's a force that's put on top of a structure and on us as well. And then an internal force is present inside the materials itself. So that's talking about like a rope. Like when you stretch a rope out during tug of war, you're actually putting an internal force on the materials that make up the rope, causing them to stretch. And if you stretch them too much, just like a rubber band, they start to break. So I give you an example down at the bottom. An example of an external force would be a car driving on a road. The car is not a part of the road. It's adding a force to it though. And then the weight of that car causes an internal force. So like the weight is stretching out the road or pushing the road apart. And if it's not strong enough, that's when we start to see potholes and things start to break. So as we move on with that, the four types of internal forces, which you'll get to practice today with the licorice if you have it available to you, are compression, so when you squish something together, tension when you pull something apart, torsion is when you're twisting something, kind of like a towel if you're ever trying to wring water out of a dish towel, and then shear force. So that's where like a force is coming upward and pushing away like that. So forces will cause a structure to have strength. And then strength is just the ability to resist a force. So if you're able to resist tension, you've got tension strength. Or if you're able to resist torsion, you've got torsion strength. I'll make sure I add this for you guys on the thing. I see that it's covered up by the picture. Don't worry about that. I'll make sure I fix that. So these next few slides just go over tension, force, and tensile strength as well as the other forces. So basically tension force is pulling a part of two materials, like pulling them in opposite directions, and the better they can resist that, they have a higher tensile strength. So all the other names match. This is the only one that's a little bit different. So we have a torsion force, which gives us tensile strength. Compression forces, again, is when you're squeezing something together, and again, the ability to resist that is compression strength. So like a stress ball has really good compression strength, whereas like an ice cream cone, if you ever compressed it, it would break very easily. So it doesn't have a very good compression strength. Torsion force is just the ability to resist that twisting motion. So again, like a towel in the dish rag, when you're trying to wring water out of it, has very good torsion strength. Whereas if you're twisting something else, it may not have as good a strength. And then shear force is like, so whenever you're ripping a piece of paper apart because you're mad or you just want to get rid of it, that's shear force. So you're pulling the material in opposite directions. So like a phone book has really good shear force, but a single piece of paper does not have very good shear force just because it's not able to resist it and it breaks pretty easily when you apply enough of the force. So for our licorice forces, that's all that I have for the PowerPoint here. So for our licorice forces, what you're going to be doing, if you have them available to you. You can use a licorice. It works the same with like a shoestring or anything like that. Even a piece of pasta. Now it's going to have really weak strength, but you can use a piece of pasta or anything that you have available. If not, I'll put a video up online showing these different forces for you, so you can at least see the examples that we would give you. So what you're going to do is you're going to take the piece of licorice, or in this case, I have just a headphone string, and you're going to draw compression force. So compression in this case is we're going to try and pull those ends together and compress them like that, and then we're going to see the force being applied here. You're going to see it very clearly when you're using your licorice, whereas for this one, it has good compression force. You're not going to see it as much. You're going to show what it looks like when you're doing this compression force. For tension, it's very simple again. So you with your piece of licorice, me with my headphone string, is going to be pulling it apart. And again, you're going to see very quickly that our licorice does not have very good tensile strength because it's going to rip apart, and it's a good little treat for you guys at the end of this whole experiment. But again, you're going to be pulling opposite directions and seeing what happens. For torsion, what you're going to do is you're going to take that licorice and start to twist it and bend it, like pushing in opposite directions like this. Again, you're going to see very quickly the effects that torsion force has on the piece of licorice. And then finally, the shear strength, what you're going to do is you're just going to pull the licorice in opposite directions like this. So me with my headphones, I'm pulling it in opposite directions like that. You guys can do that as well and see what happens with your piece of licorice. And again, you can draw what you're seeing. You can just do the experiment as you want. You don't have to draw. Just sort of give me a write-up about what you guys saw happening and what it looked like and what you sort of experienced and if you liked it or not. And that will be all that you have to do for this lesson today. So make sure you watch this video because it is important that you guys are doing it and seeing all this. And if you have any questions, again, this is on Monday, so it's not going to be due until the end of the week. So Tuesday during our video chat for 7B, if you want to ask me questions about it, by all means, go for it. Otherwise, I'll be available over email or anything like that. And hopefully, if the Zoom meetings go well, we can make this more of a regular thing. So I hope you guys are doing well. Have a good day. See you guys later.